Hello everyone and welcome to Pepcoding. I hope you all are extremely good. So today in this video we are going to discuss the first question of level 2 of graph, that is how to find the number of distinct island, right? So we are given a m cross n binary matrix. Now binary means that only zeros and ones are present in the matrix, right? So we are given m cross n binary matrix and we have to find the number of distinct island in this given matrix, right? So an island is considered to be same as another if and only if one island can be translated and not rotated or reflected to equal the other, right? So we'll find that what is the meaning of distinct, how the two islands are distinct, right? So let's take an example. Let's suppose that this is our matrix. Right, so this is our given matrix. In level 1 also we have done this question, that how to find the number of islands present in a binary matrix, right? Now what are the islands? Consider all these ones as the water, right? So all the zeros, all these zeros are the water, right? So all these zeros are the water. Now islands are what? The land. So consider one as the land. So this is the first island, right? This is the second island and this is the third island. So there are three islands present in this matrix. But the question here is that we have to find the number of distinct islands, right? So how two islands are same, right? Distinct means different, right? So how the two islands are same? Now here same means that structure wise same. Structure wise, how? Now you can see that the structure of these two matrices are same. Now the structure of islands, right? Now the structure of this island is like this, the structure of this island is like this. Now both these structures are same, right? So these two islands are same. So if we count the number of distinct islands in this matrix, the number of distinct islands is only 2, right? So two islands, three islands, but two distinct islands, right? Because these two islands are structure wise same. So we have to find the number of distinct islands in given binary matrix. So let's find out how can we do this. Now we have done the question of finding the number of islands in a matrix in the first level, right? So we are going to use exactly the same thing, but in here we are going to use another thing, that is hashing, because we want to find the number of distinct islands, right? So in that question we have used DFS, depth first search, right? In this also we are going to use DFS, plus we are going to use hashing, because we want to find the number of distinct islands, right? So how can we do this? Now we will call DFS on all the ones present in this matrix. So we'll start from here, right? So we will move in the 4 directions, that is top, left, down and right, right? So we'll move in the 4 directions. If we find a 1 in any of the direction, we'll call DFS on that one, right? So our faith is that we'll find the 1 in, if we find 1 in any of the 4 directions, we'll call the function on that one. Then this one will find all the ones here. So our island is the grouping of ones, right? So we are going to call the DFS on the first one. So we'll call DFS on this, right? Now this one will move in all 4 directions. This one will find, if we move in top, left, down and right, right? So this one will find a 1 in the down direction. So what we will do, when we call DFS on this one, we will take a string and we will add x to that string. X means that we call DFS on one of the ones of this matrix, right? So we'll add a x to a string, right? Now this one will move in all 4 directions. It finds a 1 in the downward direction. So when this one will call DFS on this one, right? So when the DFS is called on this one, we'll add the direction in which DFS is called in our string. So we move in the down direction, so we add a D in the string, right? So before going here, this one will convert to 0. We have to convert this one to 0. Why? Because when this one will move in the 4 direction, in order to find a 1, it will again go here. If we haven't convert this to 0, this one will again go here. DFS is called on this one, it will again go here. So an infinite loop will come, right? So in order to avoid this, we will mark this one to 0. This indicates that this one is already visited, right? So this one will move in the 4 directions, but no one is present in any of the directions, right? So what we will do, we'll mark this one also to 0. This means that this one is already visited, right? Now it will backtrack because no one is present in any of the direction, so it will backtrack. Now after moving right down, this one will move in the right direction, so it find the right one in here also. So as we move in the right direction, so we'll add a r in the string, right? So here now DFS is called on this one. This one will also move in the 4 direction because all the directions are either visited or zeros are present. So convert this to 0. This means that this one is already visited now, so it will backtrack from here. Now this one complete its work as it moves in all the directions, so this one will also backtrack from here. So in the string we'll get this, right? Now there's no need to convert this ones again to this zeros again to ones. Why? Because we want the number of islands. If we convert this again to 0, now when we'll move here, it will, this one will again find the number of islands, because but these ones are already included in this island, right? So there's no need to convert this one again to this 0 again to 1. So right, so we'll move here, no ones are present, so we'll move here, right? Now this is also an island, right? So DFS is called on this one, right? Now this one will move in all the 4 directions, so it will find a 1 in the right direction. Sorry, it will firstly find in the down direction, right? So mark this to 0. This means that this one is visited now. So now DFS is called on this one, but before calling DFS to this one, we'll take a string, we'll take a new string and add x to that, right? This means that we call DFS on one of the ones, right? So next we'll move in the downward direction, so add a d here, right? Now this one will try to find 1 in all the 4 directions, but in all the 4 directions only zeros are present, so convert this to 0. This means that this one is also visited. Backtrack from here, right? Backtrack from here. Now this one will move in the right direction. Since we are moving in the right direction, so add a r in the string, right? Now DFS is called on this one, right? Now this one is converted to 0, which means that it is already it is visited now, right? So it will move in the 4 direction, but no one is present here, so it will backtrack. So it will also backtrack. Now this one also completed its work, so we'll move here. Now no ones are present here, so we'll move here, right? So we'll take a new string. Since we are going to call DFS on this one, so add a x to the string. Now convert this to 0, which means that this one is visited now. This one move in all the 4 directions, but no one is present, so we'll move in the next. So our work is completed. We have traversed the entire matrix. Now these are the strings, right? Now these strings represent the path of the island, right? The structure of the island, right? So what we are going to do, we are going to take a hash set, and after the completion of each island, we are going to add the string in the hash set. So firstly, we will add this island, the path of the structure of this island to our hash set. Next, we are going to add the structure of this string to this island to our hash set. But the structure is exactly same. The strings are exactly same. So in the hash set, only unique values are present. So it will remain same, right? Next we are going to add the structure or string of this, that is structure of this island, right? So in the hash set we are going to have the number of distinct islands, that is 2. So the size of the hash set is the number of the distinct islands present in our matrix, right? So we are going to follow this approach, right? But there is a problem in this approach. What is that problem? Let's take another matrix. So let's suppose our matrix is like this. Right, so let's suppose that this is the given matrix. Now the islands are these, and add one here. So the islands are this and this. So two islands are present in this matrix, right? So are these two islands are similar in size, similar in structure, sorry, structure wise. The structure of this matrix is like this. The structure of, sorry, island. The structure of this island is like this. The structure of this island, but these two are unique. So these two are the distinct islands. So this matrix should return the answer 2, right? Because two distinct islands are present in this. So let's follow the approach we have discussed. We'll start from this. We'll take a string and add x to that before calling DFS on this function, right? So this one will move in all the 4 directions. So this one will move here, convert it to 0 because this is already visited. So this will move in the right direction, so add a r to the string. Now this one is marked visited, so it will move in all the 4 directions, but no one is present, right? No here, no here, no up, no down, right? So next it will backtrack from here. Now this one will move in the down direction. If we are following this top, left, down, right, right? So if we are following this, then it will first move in the down direction. Let me follow this one. That is top, left, right, down. That is firstly this one will move in the top direction, then left, then right, then down, right? So it has already visited the right direction. Now it will move downward. Since it is moving downward, so add d to the string, right? So now this DFS is called on this one, mark this one to 0 because this is now visited, right? So this one is also going to move in the 4 direction, but it could not find anyone in any of the directions, right? So it will also backtrack. Right? So our string is this, so add this to our hash set. So add this string to our hash set, right? So now we'll move here, we'll move here. Now DFS is called on this one. So in the string x is added because DFS is called on this one, right? Now this will move here and down, right? Since we are moving in the down direction, so add a d here. Oh, let's suppose that one is not present here. Let's suppose that one is present here, and here. Top. Let's suppose that one is present here. Then you will identify that there is something to add more in our approach, right? So DFS is called on this one, x is added to our string, right? So this one is marked 0 because this is visited. Now this will move top, left, down and right? So firstly it will move top, 0 is present, left, 0 is present, right, 1 is present, right? So 1 is present here, so r is added to the string, right? Now this one is marked 0 because we have visited this one. So this will move, this one will move in the 4 directions, top, left, down, right and down, right? So it will find that 1 is present in the down direction, right? So it will add a d to the string. Now this one is also marked to 0 because this is visited now. So it will find 1 in all the 4 directions. Now no one is present, so it will backtrack from here. It will backtrack. It is this one also completed its work, it will also backtrack, right? This one also completed its work, right? Now you can find that this path and this path is same. How? This matrix, this island has this structure, this island has this structure. Both these structures are different, that is distinct, right? But in the hash set only one string will be added because the path of both these islands are same, right? This is also xrd, this is also xrd. So we are going to get the answer 1, but the correct answer is 2, right? So this approach So how to correct this approach? We have to do only one new thing, that is right. So this here one is present, here one is present, right? So these two are distinct islands, but our approach is giving the answer 1, right? So how can we do this? We are going to call DFS on this matrix. So in this string we are going to add x, right? Hmm. Right. Right now this one is marked 0 because this is visited. It will move in the 4 directions. If we are going to take like this, top, left, down and right, right? It will move in the top. No, it can't move in the top, right? It will move in the right. It can't move in the left. Next, it will move down. Now it will find a, but let's take it as RD because previously also we are taking RD, right? So firstly it will move in the right direction, it will find a 1 here, right? Now this one is marked 0, R is added to this because we move in the right direction, right? Now this one will move in all the 4 directions, it will not find 1. So when we backtrack from this one, we will add a new character, that is, let this character is b, so we'll add a b to our string, right, when we backtrack, right? So now this one will move in the right direction, now it is going to move in the down direction, right? So it will move down, d is added here, it is marked 0 because it is visited now, right? So this one will move in the 4 direction, no one is present, so it will backtrack. Now when we are going to backtrack, what we have to do, we have to add a b to our string, right? Now this one complete its work, so it will also backtrack. When we backtrack, add b to our answer. So this is our string for this island. Now this is our string for this island. Now let's move to here. All zeros are present, we'll move here. Now DFS is called on this one, so string will be like x. So it will mark this to 0 because this is visited. Now move in all the 4 directions. Top, no. Can we move in the top? No. Can we move in the left? No. Can we move in the right? Yes, right? So we'll move in the right direction, add r to our string, right? Now mark this to 0 because this is visited. Now move in, again move in the 4 directions. It will go here, right? Again move top. Can we move in the top? No. Can we move in the left? No. Can we move in the right? No. Can we move in the down? Yes. So we'll go here, since we move in the downward direction, so add a d here, right? Now mark this to 0 because we have visited this, right? Now this one will move in the 4 direction. Can we move in the top? No. Can we move in the left? No. Can we move in the right? No. Can we move in the down? No, right? So this one will backtrack. So when we backtrack, we are going to add a b in our string, right? So add a b. Now this one completed its work, so it will also backtrack. So add a b, right? Now this one also completed its work, so it will also backtrack. So now these two strings are different. This is XRB DBB. This is XRD BBB, right? So we'll get the correct answer. That is, in the hash set, we are going to add these strings. Hash set is like this one, BDBB, and this is XRDBBB, right? So in the hash set, the size of this hash set is 2, which means that there are 2 distinct islands present in this matrix, right? So what we have to do, in which direction we are moving, we have to add that direction to our string, and when we backtrack, we have to add a character b in our string, right? So let's move to our code, right? Now we are going to use DFS, right? So I hope you have done the graph in the level 1. So what we are taking a string builder Passover. Now we are taking a string builder because the insertion operation takes big of 1 time in string builder, but it will take big of n time in string, right? So we are taking a string builder here. Now this is a global variable, right? Why? Because if we are taking this string as a local variable, this will again change again and again, right? So firstly, we are traversing in the entire matrix. So I is less than the array dot length. This is a 2D matrix, so we have to take the another variable. Array 0 dot length, right? Now we are calling the DFS on all the ones, right? So if the element is 1, we are calling DFS on that one, right? So we'll check if the element present at the position array of ij, that is if 1 is present here, we are going to call DFS on that one, right? So we are going to pass the matrix, the row, that is I, right? The row is I, the column is, the row is I, the column is j, right? But what we are doing before calling the DFS? Before calling the DFS, we are taking a string, that is a string builder in this case, and we are adding x to that string builder, right? So let's take a string builder here. This is a global variable, so add a x in the string. After adding the x, we are calling DFS. So let's write our DFS function. Let's call the DFS function. We are passing a 2D array. So here it is a 2D array. Next, I is a row, j is a column. So I is a row and j is a column, right? So what we are doing, firstly we have to mark this 1 to 0, which means that this one is visited now, right? So let mark the 1 to 0, right? Next we are doing what? We are moving in all the 4 directions, that is top, left, down and right? So you can use any of the order of these 4 directions, right? So we are going to use top, left, down and right? So firstly we are going to add the top direction. Now what we are doing, we are checking that in the direction we are going to move, is it valid or not, right? So here when we are moving, in the top direction, we have to find that is this direction, is this move is valid or not, right? So when we are moving in the top direction, what we are doing, that we are decreasing the row. If row minus 1 is less than, is greater than or equal to 0, which means that this is valid. And what we are checking, that if the value present here is 1, then we are calling DFS on that one, right? And the value present at the position where we are going to move is 1, then we are going to add DFS on that, right? DFS on array, next is row minus 1, that is we are moving in the top direction. Next is column. But before moving to the direction, what we are doing, now here we are moving in the right direction, what we are doing, we are adding a r to our string. Now we are moving in the top direction, so we are going to add the t in our t, let's t representing the top, so we are going to add t in our string builder, right? Next, this is our first move. Next move is for the left, right? So when we are moving in the left direction, we are decrementing the column, right? So this is if column minus 1 is greater than equal to 0, which means that our move is valid and the value present there is 1. Then we will call DFS to that 1. Right? But before moving to the left direction, add L to the string L. Right? Next, move in the down direction. When we are moving in the down direction, we are incrementing the row, right? So move in the down direction. If row plus 1 is less than or equal to array dot length, that is we are not moving here. Let's suppose we are here. When we are moving in the down direction, we have to check is this move is valid or not, right? Equal to less than, right? And value present there is 1. Then only we can call DFS on that one. Here also it is if equal to 1. Both these conditions have to be true if we want to call DFS on that, right? DFS since we are moving in the down direction, so add a D here. Right? Next, right? So when we are moving in the right direction, we are incrementing the column. So here it is column, here it is total columns, here it is column plus 1. That is we are moving in the right direction. Here also it is column plus 1. Here it is we are moving in the right direction, so add a R. Next, when we are backtracking, we are doing what? That we are adding a B to our string, right? So add a B to our string. Path so far. Now this string builder, right? This path so far will contain the path of the island. That is, it will tell us the structure of the island, right? Next, we have to add this string builder object, this string to our hash set, right? So let's take a hash set here. The hash set is of what? String type. That this is answer, right? After each call, add this path so far to the hash set. So answer dot add this path so far. Next, our answer is what? The number of distinct islands. The islands are contained in what? This hash set. So we have to return the size of this hash set, right? So after traversing all the matrix, that is all the cells of the matrix, we have to return the size of this hash set, right? So this is our code. Let's try to run this. Let me erase this. So let's try to run this. We are getting an error that string builder cannot be converted to string, right? So when we are adding string builder, this is a string builder object, right? The path so far, but we are creating a hash set of strings. So before adding to this, we have to convert this path so far to string. So we are going to use the toString function. Now this toString function will convert this string builder object to string. So we are getting the expected output. Now let's try to submit it. So our code is getting submitted. This means that our code is correct for all the test cases, right? So what we are doing, that we are taking a hash set in order to store the number of distinct islands, right? In order to store the number of distinct islands in our matrix. Next, we are traversing in the matrix. If we have found a one, we are going to call the DFS on that one, right? Before calling the DFS, we are doing what? That we are adding X to a string builder, right? To a string object. Consider this to a string, right? We are adding X to a string. Next, we are calling DFS to this one. this one will move in all the four directions, and this will return us the island, right? The path of island, right? So this will return us the island. Now we are doing what? We are adding this island to our hash set because we want distinct islands, right? It will move in all the four directions, that is top, left, down and right. When we are backtracking, we are doing what? That we are adding a b to our string. Now this function will give us the path of the island, right? Now we are adding this path to our hash set, because if the path of this path is what? The structure of this the island, right? So if the path is same, the structure of two islands is same, then this will only this is only going to add one time in our hash set. So we are returning the size of the hash set because this hash set will contain the this path of distinct islands, right? If two islands are same, it will only present one time in our hash set, right? So we are going to return the path of the size of this hash set, which tells us the number of distinct islands in our matrix, right? So this is all about the question. I hope the question is clear to you. That is how to find the number of distinct islands, right? So if you like the content, then give a like to this video. Thank you for watching.